You were contemplating going home, weren't you, Evan? Okay, so, whoops, not W. Did y'all have a good break? Only I heard one grumble there. What was it?
Oh, last Monday I watched 18 burn up in front of me.
You watched a what burn up in front of you?
$1,800.
Really?
Yeah.
What'd you burn?
A spin seal tool was wired incorrectly, and I watched it melt and go up in smoke.
That's not a good way to start the day off. Or end the day, whichever it was.
I bought it 2 days prior. They only used it 3 times.
Your dad bought it, and
I bought it.
Oh, you bought it.
I bought it.
Okay. Well, all right. Ryan didn't have a good break. How about the rest of you?
I went to Florida. Way warmer there.
Oh, yeah. Sure. Rub it in. I hope you got a sunburn.
Wicked.
Okay, so variable charts are different than the attribute charts that were the percentage and the U's for counts and C's for counts, that sort of stuff. We're now going to look at range charts, and we're looking for the shifts in the process variability. So how do you know if you got something that's in control? And all you did was count the attributes, and attributes were the dents in the object, or the paint was miscolored, or stuff like that. That's attributes. These are actually going to be real numbers, okay? So here we go. So I'm going to give you, 10 numbers basically, but one is for process number 1. The other one is for process number 2. I want to see how much variation there is between these, okay? And we're literally going to go find the mean. Anybody got a calculator handy? And then we're going to find the range. Say it again, Sarah. 99.8 for the first one? Okay. What's the mean for the second? $100 on the nose? Okay. How about the range? So our high was 102, our low is 98. So is the range 4? Okay. How about process number 2? 40. So ideally, which one do we have the most amount of stuff that's suspicious? Process 2, right? Okay. 1 seems to be in control because it's only ranging 4 places in the numbers. Okay. But process 2 is ranging 40 places, and we're centering around 100. So literally 80 is the lower limit, and 120 is the upper limit. Remember what the upper and lower meant? Okay. Let's have this little review. Okay. So that gives us the upper and lower for these points. And you literally could go plot these things. So we could have, I'm going to do process 2 here. So we could have the first one's 110. Let's put some positions in here. So let's do sample 1, sample 2, 3, 4, 5. So 110 would be here. 90 would be here. 120 would be up there. 100 would be right there. And then 80 would be here. So in essence, we get a graph that looks like this. Okay. All right. Now. Oh, yeah. Thank you. Yeah, because that was 90. So we're looking like so. Okay. Now, statistically, we didn't actually do anything other than I put the upper control limits at the high range and the lower control limit at the low range. Okay. So this is really okay. So it doesn't really define anything for us. So we got to do a little bit of math here. Are you all good for some math? Have I done any math, by the way, that's confusing in the last couple weeks? Luke's saying no. Sierra? Most of it's straightforward. Ryan, you got an opinion? Okay. All right. So here's how we find the control limits. Okay, I got some notes to fill in here, so let's do this. Sigma R equals D3 sigma. Okay, so this is standard deviation of the range equals so in essence, if I take this equation right here and we process this, we're going to wind up with D2 times sigma, and that will be equal to my R bar This all makes more sense in a bit. Okay, so capital D3 is equal to the 1 minus d little d3 over d2. Okay. Okay, we'll come back and play with some examples with that a little later here, but just bear with me. All the math will make sense at some point in time here. Okay, and then I'll walk you back through it, but I got to get the control equations out there. So basically, sorry, everybody got what I wrote down? Okay. I did give you guys access to OneNote, didn't I? For this class?
Yeah.
Okay. So when I pick the upper control limits here, and I basically pick the upper and lower ranges, that's not the truth. Okay. We're going to need to go look at the data, and we're going to play with it and use these two equations down here to find those. Then we're going to be able to look at stuff and see whether or not the points we wrote on there are within the upper and lower control limits. Okay. Now, that was an R chart range. The next one is 2. Okay, so now we're looking at an X bar. Ultimately, what we're going to do is an X bar and R. Okay, and that's when some of the math will start making sense. But taking it in small increments so I can get you down to where we're going will help make some sense out of all this. So here's the example numbers. We got 110, 80, 90, 120, 100. The next process is 180, 200, 210, 190, and 220. Okay. Now the fun part of this is the mean for these numbers for both processes are 100. Okay, so P1, P2. The range is 40 and 40. Good questions, Zach?
How's that 100?
How's what 100? 110, 80, 90, 120, 100. So I have one at 80, one at 90, below 100. Then I have 110 and 120.
Shouldn't the second one be 200 then?
Oh, I see which one it is. Sorry. It's been a long day today. Yes, it's 200. All right. So the control limits to an X bar Okay, and don't forget that n equals the number of samples. Okay.
What's the double X bar?
It's the average of the averages. That's cool. I should put that down. Okay, so we're going to manipulate some of the math here and reassign new variables to things to make life a little easier to keep track of. Basically, the average of the X bar, or X double bar. Sounds like a ranch out in the west, doesn't it? Plus or minus 3 times sigma divided by the square root of the number of samples n. If we substitute sigma with r bar, and that's d squared over, or d squared times sigma. Solve for sigma, we get r bar squared over d2. Then we can actually make some substitutions here. And we're going to call this new set of variables A2. Okay. Now, okay. So A2 times R bar is our 3 sigma limit. So do you remember where the sigma stuff came from? It's fair. We had a week off. Yeah, it's a 99.7 percentile of all the numbers fall within 3 sigma. Okay. Now, so what we really want to do is we want to have better control, right? Because we decided that 3 sigma is only 97%. Can we get 4 sigma? Sure, we could get 6 sigma if we really want to strive for it. Okay. So X double bar plus or minus 4/3 okay. So we're getting better in our processes. So we're going to be able to define those upper and lower control limits around what's going on. Okay. Okay. I think I need to take you out and do a little drawing here for you and get some reality check here. Yes, maybe. Zach's nodding his head. The rest of you are just smiling. So if we draw a center line here. All right. And we draw some lines in here that look like so. We have our upper control limits, but then we got different sigma levels to each one of those colors. Okay. So I did this as 3 sigma, but that'd be the numbers that we're going to calculate down the road. Okay. How are we doing on time? Is there a clock in this campus that's right? Okay. All right. I got, how many rules I got to get through here? I got 7 rules that are going to allow us to sort things out. Okay. Okay, so anything that falls outside the control limits of zone A, that's a flag. Okay, identify it as a piece of data that you're suspicious of. Okay, in the world of the math department and teaching statistics, they identify those as outliers. Okay, so if you're collecting data for slump tests on concrete, and you find one sample that actually falls outside of the 3 sigma limit for zone outside of zone A, that would be one you'd flag and go, why was that so much better or worse than all the other samples? Could be one that falls down here too, could be outside the lower half of it. It would still be wrong. Okay. And you'd want to go investigate why that was that way. Okay. So you get a slump test that's supposed to be 7 inches and it turns out to be 9. Okay. We exceeded the lower limit of zone A. Okay. If you get one that doesn't slump at all, that would put you above the upper limit and cause you problems to be worried about too. Okay. Owen's nodding his head over there. Owen, you get it? Okay. Anybody not? Alex, you look like you're scratching your head wondering what we're doing. You good? Okay. All right. Rule 2. Okay, so I'm going to put one in there, one above the C center line, one down in B, come back up into C, go down and hit one in A, and another one in A. Then I'm going back up and hit one above the center line, one back below the center line, and I didn't draw my lines far enough out. One up there, one right there, one up there, one back down here in B, and one back up into A. Okay, let me fix my graph so it extends out. Okay. So if I follow this graph, here, there, 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 up there, down, up there, down, up there, all the way down here, all the way up there. So far good with me? Yeah. Upper control limit here, lower control limit there. I have, I want to do this. Let's use green. So I'm looking for 3 consecutive points that are going to fall in zone A. Okay? 2 out of the 3 fall in zone A. So we are good here, 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 there, but all of a sudden now I got issues right here. Okay? So this second point right there becomes a violation of rule 2. Okay? Do you see the other one? Where is it, Zach?
On the right side.
The right side, the last point here, right? Okay, so that's a violation of rule 2. Okay? See how that one plays out?
So what happens if you break the rules?
Well, those are things we want to go investigate. Okay? But the funny part is there's 7 rules here. So as you're looking at all this data for an X bar or an R chart, you're trying to figure out which one of these actually causes you unnatural patterns. And what we're looking for is the fact that as I have samples of things, no 2 things should be the same. So, what's the best way to phrase that? Murder mysteries are always, the detective's always going, I hate coincidences. They don't happen. So the coincidence of having 2 parts made the same way or 2 batches of concrete coming off the truck the same way, no way in this good God earth. Okay? Just not going to be that way. Okay? I guess that's God's good earth. Good God. That would imply there's a bad God. All right, but anyways, so those are the first 2 you're going to look for. The easy one is rule number 1. When that thing pops outside the upper control limit, we got a problem there. Okay. When we start dealing with all the data, we're going to see some other things here. So let's go down to rule number 3. Rule 3. So you got to remember, you're always setting yourself back at the center line. And as long as we're having some fun here for a second, let me slide over here. So I want to remind you of this. So when we did central tendency, we got all things like so, right? And we had a mean value there, and everything clumped around this. But nothing should clump on top of one another sequentially. Okay? So that's what we're looking at here. We're looking at the central tendency limit, central tendency theory that's defining how this data should look and behave. Remember that conversation a couple weeks ago? 3. Okay. All right. So let's do the graph for this one because it's so much fun to draw lines. And I realized I got an advantage. I can do colors for you. Whoops, wrong place. Okay, first point here, next point there, next point will be up above the center line. We're going to be here, there, up here, back here, down here, one on the lower side of the center line, one back up on the center line, one out in zone A, back into B, then we're going all the way down to B on the lower side of the center line, then back up to B and B, okay? Like so. Okay. So I'm looking for things that I can flag with Rule 3. All right, so where do you see the first one? So remember, 4 out of 5 successive points fall in zone B or beyond on the same side of the center line. So find your, what's that?
7th one.
1, 2, 3, 4, 5, 6, 7. Yes. Okay. Is there another one? Zach's got it. Before he answers, anybody see the other one? Where is it on?
It's at the end.
The end. Okay. This one over here. Okay. Is that where you saw it too? Cool. I got a job for you in the life. Cool thing about quality control is you get a clipboard, a hard hat, paid a lot of money. and you get to tell people what to do. Okay. Everybody good on rule 3? Good, Luke? Okay. All right. 4 more to go. All right. This one doesn't have as much to do with drawing, but that one becomes rule 4. Okay.
But that was only 6 points.
What's that?
That was only 6 points.
Oh, did I miss one? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I did miss one. Where did I miss it? Oh. Right there. Sorry. 2, 2, 2, 2, 2, 2. Okay. Now, I always loved this one when I first learned it, and I just accepted it in time because you just don't argue with logic sometimes. But 8 or 7? Really? What makes it 7? What makes it 8? What you're really looking for is the fact that you've exceeded the center line. So technically, if you've exceeded the center line and that's where your new chart is, you should probably have a new average. So your center line is going to go up. But why did it go up? That's the things you got to investigate. So as you do your chart, we've been using concrete. I can't think of other good one right now other than slump tests. But I've been getting stuff from Potsdam sandstone, and all of a sudden Upstone brings me the next load. And for the next 7 loads, I'm in a different supplier. You don't know it until you go look at the data and then go figure out where those loads came from. At that point, you're already into the process far enough to know that there's something wrong, but then you sit down and you replot your graph. Okay, so now you have a new mean and you have a new upper and lower control limit, and you see where your processes are going. Okay, so that's what this one tends to tell you to do. Okay, all right, rule 5. Let's see if I can do these last ones. And no, we're not going to do them all. Man, every clock in this building screwed up.
5 minutes.
5 minutes. Well, we'll get rule 5 here, and then we'll do the last 2 on Thursday. So this is really looking for trends in the data. So So we got one here, we got one there, one up there, one there, one down here, one there, one there, one there, one there, one there, one there, and so on. Okay. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So it's not a matter of anything being on the one side or not. It's looking for those trends. Nothing should be trending in one or more directions, or one of the 2 directions. Okay. Make sense? Okay. Yeah, we're not going to finish. No. Cool. I'll finish those on Thursday. So, guys, have a great day.